Yeah. Hi, everyone. So we're going to get started. Welcome to the IETF INTAREA working group meeting for IETF116. Can you close the folder? Just 1 second here. Okay. There was a little echo. I hope it's gone now. Okay. Yeah. Okay. So I hope this is better now. All right. So my name is Juan Carlos Zúñiga Cisco.
Hello everyone, Wasim Haddad Erickson.
So let's start with the usual note. Reminder that this is an IETF meeting, and therefore we are participating. You agree to follow the IETF process and policies. So if you are aware of any contribution covered by patents or patent applications, you must disclose it or not participate in this discussion. You acknowledge that written audio, video, and photographic records may be made public, and the personal information that you will provide will be handled in accordance to the IETF privacy statement. So please treat others respectfully. Contact the Ombudsman if you have any questions or concerns, and you have the list of all the BCPs that can answer most of the questions if you have any. Please do sign in to Miteco with the data tracker. You will see from the agenda, we need this to take your attendance and to see who's in the queue. So we will be looking at the queue for whoever wants to raise his hand, remote or local, and we will follow that. If you are remote, please keep audio and video off and wear your mask unless actively speaking at the mic. Same thing here, please, if you can not use audio to avoid issues. So the agenda has been posted, and if you have any technical issues, you can contact Miteco or the tools team or the IT team at this address. So as a reminder, minutes are taken. The meeting is being recorded. Your presence is logged. Blue sheets, again, from the data tracker, and everything will be made public. So yeah, next thing, do we have a minute taker? Can someone help us take notes? We have the nice tool that is recording the text, but we still would like to have someone help us with the notes if possible, so that we can record any important decisions. Doesn't have to be one single person.
So Eric Ving, responsibility for INTAREA. As a reminder, no scribe, we cannot start the meeting. What we need to do is basically the questions and the answer, right? Obviously, no need to type the slide on the long discussion, just a summary of the questions and the answer. No volunteer. You will get a free coffee.
Okay.
Thank you.
Thank you very much. If you can send us or you can just put in the chat your name so that we record it. Thank you very much. Okay, with that, we move to the agenda. So today we had this 4 items. We're going to talk about the status update and a liaison letter we got from IEEE 802. Then we're going to move on to talking about the draft INTAREA RFC 7042 bis, IANA considerations and IETF protocol and documentation usage for IEEE 802 parameters. The third topic will be IP addressing with references by Valdemar. And finally, service-aware networking framework and data plane solutions. Any questions or bashing on the agenda? Okay. So we have a request for an announcement. We'll leave that at the end if we have the time. Yes. Was there someone in the queue? No. Okay.
I think by mistake.
All right. So we're going to start with the discussion about this liaison letter that IETF received from IEEE 802. And this is related to the presentation that we'll hear from Donald shortly. So as you can see, we had this formal liaison. That's a way to communicate between SEOs, and IEEE 802 is the one in charge of forwarding this information on behalf of the 802.1 group and the RAC, or Registration Authority Committee, sending us some comments on the draft by Donald. So you can see the link to the liaison letter if you want to see the full document with all the specific comments, but I'm sure Donald will address those shortly. What I wanted to show you is the header of this liaison letter, and the important part, I guess, that we need to consider is the blue that I'm going to quote now. It says that IEEE 802, we recognize value in providing background information for the reader and recommend that a statement be included that the reference sources are the definitive references being IEEE Standards 802, IEEE Standards 802.1q, 802.1ab, 802.1ac, including any approved amendments and revisions. And then they note that IEEE 802 itself, which is a different document, is currently undergoing revisions, and they welcome participation in the process. They also look forward to reviewing the next draft of IETF RFC 7042 bis, because they would like to see the draft after it's been revised with the comments that they have sent on the document. So we will have a presentation by Donald on this draft, but let me first ask if anyone has any questions regarding this liaison letter or the intention from IEEE 802, if it's clear. All right. So we'll defer then the discussion until Donald's presentation. One more update, and this is because the topic of ether types is also related to the draft, and that's something that was happening at the IEEE 802 plenary a couple of weeks ago in Atlanta. So it's been noted that there are discrepancies between the public ether type lists. There is one list that, and you see the first link there from Standards OUI, IEEE.org, ether type Ethernet. And then there's another one that we normally discuss here, IANA.org, assignments, IEEE 802 numbers. And as you may be aware, and we've been discussing in the light of 7042 bis, the official ether type list is owned by the IEEE RAC, and that's the absolute reference, IEEE.org. However, there are important practical, in this case, protocol usage information that is only found in the IANA.org list. The issue is that these two lists are often not in sync or not maintained at the same time, and that has created some confusion in the industry. So we've been talking about coordinating with the IEEE RAC so that they can include the practical information that we produce here through or from IANA and the ISG with the normal process. And eventually, why not deprecate the IANA page to avoid confusion, redundancy, maintenance, and other issues that we are currently facing and trying to fix from time to time. So the intention would be to make the IEEE list that it's actually not in a very clear way, but it's the official source, more readable, and that it could include, let's say, a new column that is useful information from IANA or something like that. And that part, we can transfer whatever we have in the IEEE 802 numbers. This doesn't have to apply to every single ether type because not every single ether type is associated to an IETF protocol. But at least the ones that are important for us, we can highlight them. And that way, it'll be one single reference and people would not be confused about it. As a note, and again, in the context of 7042 bis, this is explained, an expert review and ISG ratification process exists already to officially contribute information to the IETF rack from IETF approved sources, meaning that it's not any information that will show up in this ether type list coming from IANA. It'll follow the usual process, the formal process that we have to basically request an ether type or request any changes or additions to this list. So that is discussion happening right now between the organizations, and there's a coordination meeting happening between IEEE and IEEE 802 and the IETF or IAB that where this will be discussed. Okay. All right. So if there are no more questions, I guess we can move on to the next presenter, which is Donald.
Hello. Okay. This also actually has a slight impact on 7042 bis, the last slide you showed about ether types, because there was a request in this working group for clearer information to be in 7042 bis about the actual process by which an ether type gets applied for from the IETF, from the IEEE for an IETF protocol. So I added material to 7042 bis, and it says that the primary contact for the IANA ether types registry is the person who does it. If the IANA ether types registry goes away, there presumably isn't a person in charge of it. There isn't a primary expert for it. Currently I'm primary expert and you're alternate expert, but so need to do something. Mm-hmm. That seems to imply another change in 7042, but this maybe.
Yes, indeed. But right now the change hasn't been approved or made. It's still in discussion. So I agree. If ever this is changed, it'll have implications on 7042, definitely.
Okay. So this is you already know this is about RFC 7042 bis, that draft. Next slide. So this is just the pointers, and you can download these slides. You can have nice pointers to the cover note and the actual liaison with a full marked up draft. Next slide.
Just one question. Are people seeing the slides changing online? Like I'm on slide 2 summary. Yes? Because there's a disconnect at least between our computers. Okay. So I'll keep going and let me know. I'm on slide 3. Types
okay,
of
so okay, so I did a quick pass, and this is a little rough, so it certainly could be off by a few, but there seem to be approximately counting similar changes to this separate, so to speak, about 62 suggestions from IEEE 802. And I tabulated them here. So there's like 19 little nits or just wording changes and not any big significance. There's 13 cases where the word ether type occurs and they would like the T capitalized. There's about 12 cases of tweaking references or definitions. There are a couple terms they wanted definitions to be added for, some references to their documents that they wanted moved from informational to normative. Nothing's, these are all pretty innocuous things. There's 5 cases where they wanted vendor-specific change to organizational-specific. I think vendor-specific is more commonly used in the IETF and was earlier used in IEEE documents, but I guess they've changed to the more correct, actually, because these things are basically based on OUIs, which are organizationally unique identifiers. So it should always have been called organizational. As in the cover letter, there's 4 cases where they want some wording changed or added to emphasize that anything it says about, certainly anything it says about process in it, in 802 is informative, and the 802 documents are authoritative and so forth. It used to be that MAL, which was a MAC-L allocation, was considered to be equivalent to an OUI, but that's apparently not true. So that's just a trivial couple of changing of wording here and there. So there were 2 improvements they wanted, and that's getting down low enough that I could say what they are. One was where it said it says in the current draft, the IEEE has done something, and they wanted to say IEEE 802 has done something. Seems like an improvement. Another case, they just wanted a few words to clarify bit ordering. The bit ordering in the draft is the standard IETF kind of bit ordering, but there's just no problem sticking in a few words just to clarify that a little bit. There are 2 cases where they wanted to remove information that's currently in the draft, which as far as I know is true, but they didn't want it to be there. One is that it says that they have in the past considered, IEEE in the past has considered 128-bit MAC addresses. I think this is not only is true, there's actually an expired IETF draft which mentions this, but they just don't want the draft to say that, I guess. In the other case, it talks about certain kind of ether type and LLC protocol encoding chaining, which I believe is required to be supported, and they would like that removed. I don't think these are big deals. Skipping to the last item, it turns out that there's been an off by 1 error in this and all previous versions of this RFC, which is the maximum length of the payload in an LLC encoded frame, where it said less than, and it should have said less than or equal to. So it's hex 5DC should have been hex 5DD, or the inequality should have been fixed. So this gets down to 2 suggestions from them that I consider to be possibly problematic. Next slide. So the first one is the draft. There's a new thing called SLAP, which subdivides the previously local MAC addresses. I think it's currently still optional, into 4 quadrants. One of them is called standard assigned. And I was in the room at 802.1 when this was being discussed at some point. Haven't actually consulted necessarily the most recent edition of the document. And the idea was these are MAC addresses that are assigned through some kind of local allocation protocol, kind of the way, DHCP assigns IP addresses and things. So the draft currently says that they would be assigned by a protocol, but doesn't say anything further. They want that to be changed to say it's assigned by a protocol specified in an IEEE 802 standard. And I'm not sure if the original document says that, but that's what they wanted. And that seems like not true or correct, because we have an RFC on the standards track, RFC 8947, which tells how to assign MAC addresses using an IETF protocol. So admittedly, they didn't ask for it to say only by a protocol specified in an IEEE 802 standard. Nevertheless, it kind of implies that. And the other possible problematic change is they wanted some changes, very trivial, but changes in the IESG statement, which I included as Appendix B. So one is just capitalizing T in either type, and the other is the current IESG statement refers to IEEE standard 802 lowercase a, which was an amendment which has since been rolled in, so they would prefer it to refer to the main document. And I don't think these are problematic changes, but the ISG has to make them because I don't think we can make them in the working group. Let's see. Go
So quickly on this one, regarding the responsibility for INTAREA, of course, we will update the typos, right, in this ISG statement.
Okay, so I guess our AD will take care of that. Next slide. So this is my suggestion for what we should do. We should thank them for their suggestions. I'm working on a -02 version of the draft. One thing is this, it's a little bit more work than you might think, just because this draft and all the previous RFCs, RFC 7042 and the previous RFCs in the series, each of which obsoleted the previous one, were all done in NROF. So I've decided to finally convert it to XML. So it's taking a little bit of effort. So I can put in the what I assume are non-controversial changes, put them in there. People can look at the diffs and changes, see what they think about them or something like that. I think we should resolve these problematic changes the way we want, and this basically go ahead and do a working group last call, which could be longer than usual. And of course, notify the IEEE IETF coordination mailing list, which has people from 802.1 on it, as we do these various steps. And that's my opinion is what should happen.
Okay, so let me put myself in the queue. Thanks, Don, for the presentation. So I'm trying to see on this path forward. So I agree with there's a need for a new version, and they were requesting to review this new version. I also agree that there are some non-controversial points that can easily be addressed and should be addressed in this new version. For the problematic suggestions, I'm just wondering if this is something that requires a new discussion, because I would like to avoid cycles in the communication with IEEE. So
I would also, so I think that basically I can effectively accept all the suggestions, maybe not the exact wording, but of them for everything but the first of the problematic ones, which maybe I don't know what we should do exactly about that. Obviously the IESG will fix the second one, so that's not a problem.
So the first one,
Yeah.
the way I understand is, you're right, like not all protocols are specified in IEEE 802, so, but that's something we can clarify in the liaison letter, right? So we could say something in the liaison letter along those lines.
Yeah.
We produce a version that addresses it the best way we can, and then we wait to hear from them.
I guess. The only problem I have with that is that, you know, when this was brought up at the last IETF meeting, and I presented the draft, there was nothing official, but informally I was told that 802 was meeting the following week and we should hear back maybe at the end of that week. And we heard back 4 months later. So.
Yeah, unfortunately, you know how they work. It's you have to have the official meeting and vote and hold that meeting. So I don't know that the RAC not always meets at the plenary.
I have nothing. I have no knowledge about RAC meetings, but IEEE 802.1 meets every 2 months. They have 6 meetings a year.
Right. And the RAC, I don't know if they meet at every plenary, so 3 times a year.
I have no idea.
But I guess what we need to do is indeed send them, create the new version, draft liaison. That's something we need to coordinate internally with the IAB.
Yeah.
And then let them respond as soon as they can.
We can head that way. I'd be happy to contribute to the liaison. You know, obviously it needs to be. It would come from it can come from the inter-area working group. IETF working groups have the authority to send liaisons. So
yeah, we can propose it and then send
and
it to
it should be reviewed by all the appropriate people, but originating from the chairs basically. So Well, we can follow that path, and see what happens, I guess.
So I personally don't have an issue in doing in parallel the directorate reviews,
Okay.
the last call, but we do need to wait to hear from them because that's what they were requesting to check all the vision. So plus, of course, as you mentioned, there's this other discussion that is taking place. So
yeah,
we have to see what is their take.
Yeah, obviously, any direct reviews or anything like that should hold off until at least this -02 is posted.
Right.
Yeah.
So we have Janos on the queue. Yeah. Do you want to turn on your phone? Your mic, sorry. Janos, can you speak up? You have to click the unmute audio if you want to speak up. Oh, well, he's basically putting in the chat that 802 votes are only taking place during 802 plenaries, so that'll be like 4 months. Anyway, so I agree. We can at least take action on our side, and then wait to hear from them.
I don't know, does anybody in the room have questions or comments?
No?
Excellent.
Okay, thank you very much. So next in the agenda is Valdemar.
Okay, I'm going to describe the draft IP addressing with references. I'm going to get straight into it because it's just 20 minutes, so I don't want to waste time on too many introductory.
Maybe can you speak closer to the mic? Maybe. Thank you.
I'm going to get to it right straight into it to avoid too many introductory sentences. So IP addressing with references. So first, what is a reference in this context? It is essentially a number, an opaque unsigned integer like 134276. The IP ref address, which uses the reference, is a combination of a standard network address and a reference. So in a IPv4 or IPv6 world, it would look like, for example, 192.0.2.123 plus 3427, where 3427 is just a reference. Again, it's some number selected by local authority, local to the local network. In IPv6 world, it will be similar thing. So 2001 DB8 123 plus 2371. Again, this is another reference selected by the administrator of the local network. So we're talking IPv4 and IPv6, but actually any network address works plus reference. Next. I have to make sure that it's well understood that this draft discusses private networks only. Okay, so IPref is for private networks, like private to private only. But you should notice that so-called public addresses are merely exposing hosts located on private networks already. So that last point is very, very important, especially down the line. I think this is really the key. Right now, it might not be obvious why this is so, and maybe not that important at this point. At this point, I think it's more important to understand how it works. Just a little bit of a background. The motivation came from helping exactly private to private networks. It's with the case of private networks that are disjoint and ability to exchange information in a peer network manner. So the obvious thing that came to mind was like not traversal, duplication of IP addresses, that sort of thing. What I really wanted to do is to make it work without negotiations. So that is an important element, that this could be done without any need to agree on something or not agree to something. So the private network can simply just define what it is and just send it out there and it's gonna get there. So that's the idea. The next logical step was IPv6 added to it, because obviously some of those private networks might be running different protocols. So we're talking traversal of network protocol space. So that works. And again, we're talking IPv6 to IPv4, but it really works for anything. I think this is important because it allows to develop other networking protocols. So that sort of makes it easier with innovation. So it helps innovation a little bit. Now, obviously, we know IPv6, IPv4, and we know how it goes for 25 years and so on. That will help IPv6 in a big way. So especially that last point, if that is covered, then we should have no issue with IPv6 if IPref is adopted. Next. So whatever motivation, whatever big plans, let's try to understand how it works. So this is like the slide. It's a little bit busy because all elements in there. So I'm gonna describe it, what to look for. So we have two simple private networks, okay? There is a network A on the left side. I try to make it easier, so the addresses on network A are odd. And there is the other network, also private, on the right side. And here addresses are even. This is just for illustrations to make it easier to follow example. They are connected via third network. The third network could be anything, but of course, for practical purpose, we're talking internet here. But I would like to mention that one particular case of a third network is a null network or no network whatsoever. So you can, I guess, connect all those routers directly with some sort of a cable or some radio link or something like that. So let's get back to the internet. So purposely, one of those networks, the one on the left is IPv4 network, the other is IPv6. In the draft, I have an IPv4 only example, so I thought it would be helpful to show how it works with mixed protocol spaces. So the network A has a gateway 2001 DB8 AAA:1. Network B has a gateway on the very same internet 2001 DB8 BBB:2. And then on the left side, there is a host A5, 172.17.1.5 that wants to talk to host B. And how is it going to do it? So the first issue here is to acquire the address of B4. And of course, A5 is a IPv4 host. He has no idea what IPv6 addresses are, and he doesn't have to, because the way IPref works is that the local networks do not know what the addresses are of the peers. They don't even know what the protocol is run at the peer networks. So instead of like a real address, if you will, it's getting an IPref address. That IPref address is allocated by the local network B. So whoever owns it allocates it. And there is no negotiation whatsoever. So whatever they define it is. That's it. This could be passed to the network A through many means, including DNS. So DNS is not required. That's the example in the draft. Here is, I'm using the DNS just to show that, that those addresses are publishable. So network A5 tries to resolve address of host B4 and going through a local resolver, he gets the answer. And the answer is an IPref address. So it's 2001 DB8 BBB colon 2 plus 4286. Now that's IPv6 IP address is the address of the gateway so that you can get to the right network. The reference is some opaque number, as I mentioned before, that network be allocated. So for host A5, or rather for the network A5, whatever that means, it doesn't matter. It's totally opaque. You just take it. Now there is a little bit of a complication. A5 has no idea what IPref addresses are because A5 runs just a straight IPv4. It is the gateway that understands IPref, okay? And this is the gateway that can see references, which are in the packets, by the way. So those references will go into the packet between the gateways GWA and GWB. But they will not appear on the local networks. So A5 will never see a reference. So for this to work, there is a concept of a projection or an encoding network. So that the resolver realizes this is an IPref address, which A5 will not understand. So it encodes it into what A5 does understand, which is IPv4. So this is what the encoding network is. And at the bottom, it says encoding network 10.128.0.0/10. And note that that IPref address presented by the network B is encoded as 10.128, sorry, I can see it from 10.128.222.14. Okay, it's just whatever resolver decided to allocate. So now A5 has the destination address. The destination address is 10.128.222.14. And what it does, it sticks it in a packet. It's an IPv4 packet and just forwards it. It goes through the gateway A, who understands IPref addresses in all the mappings and does the correct mapping, sends it to GWB, and GWB decodes it, if you will, remaps it to something that before understand, and the packet gets there. So this is in detail how it works. That's really the essence of the whole thing. It's not really that complicated. So starting with A5, so I already mentioned destination is B4, which is published in DNS as 2001 DB8 BBB colon 2 plus 4286, which was encoded as 10.128.222.14 by the resolver. So A5 has a source, its own 172.17.1.5, destination 10.128.222.14. The packet gets to the gateway A, and then some address writing is taking place. So first, gateway A realizes that the source address 172.17.1.5 does not have an equivalent IPref address, so it allocates it. It can do it because it is in the control of that local network, so it can do whatever it wants. And it allocates 2001 DB8 AAA colon 1 plus 3159. There could be some mechanism, maybe random, maybe some other, whatever. So now we have a source IPref address 2001 DB8 AA1 plus 3159. You might notice that the box is shown here, although I'm not consistent, but at least this one is wider than the original. It's because that reference goes into the packet now. It wasn't there before, but it is there now. Now, destination, gateway A knows about the mapping that the resolver did, so it just takes whatever resolver mapped. So the destination is 201 DB8 BBB colon 2 plus 428D6, which is the IP ref given to network A by the admin of network B. So now its source and destination are both IP ref addresses and can be forwarded to gateway B. So it goes over the internet, whatever on the way in the internet, those routers, devices, they don't, I mean, they ignore references, they're there, but they ignore it. They just forward based on the standard IP part of the IP ref address, okay? So it gets to gateway B. And then, is there a question?
Yeah, there are two people in the queue ask the questions, and we have 5 more minutes. So it's up to you if you want to take questions right now or. Okay, so Anthony.
Anthony Liquid. I'm just struggling to understand what's the problem this is attempting to solve and how existing solutions don't solve it, because I'm a little bit confused.
So NAT traversal does not have a solution, the way this works.
But you've got things like IPsec and other VPN type tunneling solutions. And my second concern is if we're publishing stuff in DNS, privacy.
So,
Yeah.
Okay, I mean, I don't see any issue with DNS, okay? It's just published the way the DNS does things. Does IPsec solve the problem? No, it doesn't. IPsec is a negotiated solution. What I wanted something that does not require negotiations. Something that you can just send it and it works. There are several other ideas that are either single protocol domain or require negotiations. So this traverses NAT, no negotiations, traverses protocol space, no negotiations. Not only IPv4, IPv6, it's anything.
No negotiations for private IP space sounds very scary. My private IP space is private for a reason. And if I want something to reach it from remote, I want to negotiate that because I want to secure that. Just my 2 cents.
Okay, so really scary. That's why you're getting a reference that is opaque. You can do whatever you want with this reference. So, I don't know, if IPsec doesn't scare you, this shouldn't be scary either. Okay. There's another question?
No.
No, okay. Let's get back. I want to finish that example. Okay, so at gateway B interprets the same references but differently got gateway A. So it gets the source address that is an IPref address, doesn't know anything about it, so it encodes it. It can do it because this is so local, so it can assign it whatever address it wants. So it allocates FDEE colon EEE colon AA 11, just totally arbitrary allocation. Destination, well, that's easy because this is the destination that it gave to network A to begin with, so it knows that that IPref address corresponds to this host before, 2001 DB8 2222 colon before. So after that, references are dropped and the packet is forwarded to B4. And B4 is getting the packet. It's an IPv6 packet. All addresses are IPv6. There are no references there whatsoever. It doesn't even know that there was IPref or anything like that. So it processes that it can come back.
So you have 1 minute and a half if you want to start dropping. Next.
Yep. Some notes, IPref name resolution, already mentioned that, so just quickly, so the addresses are publishable. Works pretty much like DNS name resolution. There are some things here with like record type. You probably need the record type, but we worry about that when you get to that point. For now, it could be simulated with text records. Next. Some general notes. So IPref is an address writing technology like NAT, but it operates entirely in layer 3. So there is no reaching to ports or below or above whatsoever. This is pure layer 3. IPref gateways, I was actually asked about that, so I made it clear. Maybe edge routers, but they don't have to be. They may be located inside local networks, behind edge routers. If this is an IPv4, it could be located behind the NAT, so to speak. So that's no problem. Another point, only IPref gateways deal with references. So this is the point, who puts reference into the packet and who is dealing with complexity. So this is only the gateways. Everything else is just standard devices. All local host routers, switches are standard. All internal host routers and switches are standard. Also want to mention IPref does not replace anything. Does not replace IPv4, doesn't replace IPv6, does not replace VPNs, NAT or firewalls, none of these.
Okay. Thank you very much. So we're out of time for this presentation, but if anyone has any questions, please take them to the list. Thanks.
Thank you.
So we have to move on to the next presenter.
Good afternoon, everyone. And on behalf of the authors, I will present a framework of service to our network, as well as some solution suggestions to the data plane and the end-to-end forwarding solutions. Next, yeah, thank you. Okay. The first page is supposed to be use cases. So I'd like to say that the use cases of cats could be referenced right here for the edge computing size scenario. And on top of that, actually, what the service area network is designed to address is the scenario where the service needs to be identified by the network as well as the SLA requirements. This page is simply a generalization of use cases of SAM. When it comes to the cloud topology shifts, while the computing resources to migrate to the edge and even the super edge size, so from the perspective of interworking, the topology that changes significantly right here. So we believe the network needs to adapt in terms of its capability of being aware of the computing resources as well as the service requirements. And next page, please. Next slide. Okay. So here's the a whole picture of a framework of a service area network, which we designed to enhance the current network. From the point of view of the whole framework, the SAN framework actually focuses upon only within the dotted line. But even though it's the L7 and the application level situations also involved, but we would like to focus on near 4 and near 3. That's also why the drafts have been posted in the first place to the interior area rather than the routing area. Okay, sorry. And the central part of the SAM framework is the service identification label, which has been designed to be an interface between the service as well as the service requirements and the underlying network, and between the network, the routing network and the cloud side and computing. So, and also from the point of view the user, and the service identification label right here could be recognized as an easy access to the service rather than the traditional IP address and port, which could not indicate exactly what the service is. So, but a service right here and in service area network is not designed for everything. It's simply designed for the computing and networking sensitive services, which we would like to call it the fundamental and the common services, such as the highly interactive service, the cloud game, and metaverse, some kind of that scenarios. So when it comes to the other services, which are not computing network sensitive, the service traffic should be transmitted and forwarded as it is, just through the ongoing URL, DNS, and JRSB, something like that scheme. Next slide, please.
So, sorry, you have 8 minutes just because you have a few more slides, so that you manage your time if you want to take questions.
Okay. I will try to.
Thanks.
Okay. So as far as the SAN control plane, we have 2 dimensions of the consideration. The first one is the awareness of the service requirements. We believe the service requirements from both the networking and the computing should be open and should be visible to the underlying networking through a lightweight channel. So we would like to say the centralized control plane should be employed for the raw list of the service requirements. And when it comes to the awareness of the service-related networking and computing resources, we actually divide the resource status into two types. The first one is the global service resources status, which is recognized as quite stable and comparatively static information, such as the type of service which the cloud side provides. And the Jeller node, the computing and the computing node and the memory, such like. While the highly frequent service resource status will be maintained at another entity, which we call the local service resource status. So when it comes to a quite wide area of service-related network computing resources wearing, we strongly recommend centralized control plane. When it comes to limited domain, we believe the distributed control plane will be more suitable because it will gain the benefits of fast and the efficiency of the awareness of the resources. Next slide, please. We have two options for service identification labor location in the IPv6 header. The first one is the dedicated encapsulation in the extension headers, which could carry comprehensive metadata and also can share flexible service identification labor lengths. We also have another option for the leverage of the existing header fields to indicate the service identification, such as the resource and destination address, in which the prefix could be leveraged, and as well as the flow label in the IPv6 header. And when it comes to the service identification label-based routing, here, when the service traffic arrives at the send ingress, the designated header field will be extracted and mapped with the cell indexed policy as well as the global service resource status. So the cell marked traffic could be routed accordingly. When it arrives there.
So, Daniel, sorry to interrupt you for the sake of time. Over the mailing list, we discussed about 3 questions: whether it's fixed, is it similar to the CAT working group requirements? What are the differences between the API mailing list intent? So if you can do on those differences, that would be very useful for all of us now.
Okay. I intend to address your comments by the end of the presentation, but now I'll make it.
You have 3 minutes to go.
Okay. Let's complete this page, and then I will answer your questions from the mailing list. And when the service traffic arrives at the cloud side, the traffic could be treated as the explicit service residing at the site, which could leverage it to make cell-specific forwarding and scheduling, such as load balancing. And it could also be global at the cloud site. And when it comes to the comments and suggestions of Eric in the mailing list, the difference between cell and APN ID, APP ID in the APN mailing list, I would say cell right here is designed as a service profile, which allows to then and manage it and published by higher layer and application system. So rather than identified as the flow, a flow label or flow identification, that's the difference. And the second point is the cell will be encapsulated and carried from the terminal rather than from the SAM ingress. So within the SAM framework, both SAM ingress and egress will not add or remove the SN header on this occasion. Okay, next slide. Next slide, please. Here's the, we simply make the design of the SAN header encapsulation, and it's simply the first version of our solution. The SAN ID indicator right here it could be the metadata, including the length of SAN ID, such as 32 bits and 64 bits. And the S will indicate the presence of a stream ID, which is gathered locally by the terminal, and which is used to indicate the service flow, but it's optional. And R is designed to indicate the presence of optional reserved parts, such as the security consideration, which we will post in the forthcoming drafts. Next slide, please.
So you have 1 minute to wrap up, please.
And here's the hierarchy service routing. Actually, I mentioned in the previous slides that under SAM framework, we divide the service-related resources into two types. And we suggest to maintain them at the global service resource segment, such as the SAM ingress and local resource status, which corresponds to infrequent update status and frequent updates respectively. Next slide, please.
Sorry, but we're out of time and we need to close. The meeting is finishing now.
Okay.
But thank you. I mean, I see you have many more slides. We're at the end of the hour, and we have. So please take the questions to the mailing list, and we have, I guess, 30 seconds for an announcement for a draft that was published yesterday.
Okay. All right.
Yes, if we can take questions on the mailing list.
Okay, no problem. Actually, we started the discussions in the mailing list for a couple of terms issues.
Thank you.
Yes, thank you. Thank you very much.
Andrew?
Comments?
Hi, Andrew Alston. Thanks very much for giving us the 30 seconds. We just wanted to say that we've put a draft out onto the list for trusted domain SRv6, and it's just a request if people can take a look at the draft, give us comments, feedback. We will be pushing a draft 01 of that within the next probably 24 hours, and I wanted to say thanks very much to Adrian and the guys who have commented. Basically, all the draft is trying to do is kind of enhance the security around SRv6, and we would really welcome any feedback, comments, positive criticisms, and yeah, the authors are ready and waiting to respond so that we can move this along as fast as possible. So thanks very much.
Thanks, everyone. So any feedback on the mailing list, because we're out of time, but thanks everyone for attending the meeting, and see you next time.